In this video, we're going to visit topic 8.5, finding the area between curves expressed as functions of y. So your essential question is, how do you find the area between curves expressed as functions of y? And your I can statement is, I can calculate the area between two curves horizontally. So we're going to start with horizontal representations of rectangles. So basically, we're going to find the area of the two graphs bounded by these equations. So we're going to have to sketch them. So the best thing I could do, well, if I started actually with this one here, start with the one we know. That's definitely a picture of a line. So we know that if I were to solve that for, say, for y instead of x, that would be x minus 1 equals y. So I know I could graph that. So I have a y-intercept of -1, and I'm going to go up 1 over 1. I want to try to be as accurate as possible. And then the other one's a little bit trickier. So there's a couple of things I could do on this. I could go ahead and solve it for, I could solve it for y if I wanted to. So if I did that, it would be x minus 3 equals -y squared. And then I would get -x plus 3 equals y squared. And then so this is kind of a little bit messy here. So that might not be exactly the way we want to do that. So the other thing I could do is I could just do a t-chart. So let's look at what a t-chart would do with that, just to get an idea of the sketch, because sometimes you just have to know. This would be my y value actually, and my x value, so it's a little bit backwards. So let's start with 0. We probably need at least 3 points. So if I put a 0 in there, I know that I would get a 3 out. So I know the point x at 3, y at 0. It's a little bit backwards of the way we normally do it. Now if I'm going to put in a nice square number of 1, so I know that, or actually it's not a nice square number of 1. I'm going to put in a 1. It doesn't have to be a square number. So 1 squared is 1, 3 minus 1 is 2. So I know the point out 2, up 1 is on the graph. And then let's put in let's go the other direction. Let's go -1 for the y. So -1 squared is 1. And then it's still going to be 3 minus 1, which is still going to be 2. So it could also be out 2 and down 1. So now it's definitely, we know it's got to be a parabola of some kind. It's just laying on its side this time instead of the way we normally see it. And I don't know if I sketched it completely right, but it's at least enough to give us an idea of the region that we're looking at. When it's horizontal like this, we're always going to do the right minus the left instead of top minus bottom. So my right function is the blue function and my left function is the orange function. So we're still going to find the area by integrating. I need to figure out where they're actually equal to, right? So I'm going to have to do that calculation. So I am going to set them equal to each other. So 3 minus y squared equals y plus 1. I'm going to move these both to the right so I get a positive leading coefficient. So 0 equals y squared plus y. I subtract the 3 over, that gives me -2. So in my magic x, I need two numbers that multiply to -2 and add to 1. I'd probably use 2 and -1. So we get y plus 2 times y minus 1. So I know that using zero product property, I'd get -2 and +1. So I'm going to integrate from -2 to 1. I'm going to do the right function, which is the 3 minus y squared. Always subtract, just like we did with the others. And then I'm going to do the orange function, which is y plus 1. And then, of course, we're going to put a dy after it. And we're using dy instead of dx because I'm in terms of y right now. All right, I'm going to erase the messiness of this over here. Okay, so let's go ahead. I could simplify that. Let's simplify that a little bit before we integrate. So we'd end up with, let's see, this negative would get distributed through. So that's going to be negative and negative. It looks like, so if I combine my like terms, I'd have 3 and -1, which would be 2. I'm going to put it at the back. And then I'd have -y squared minus y plus 2. All right, now let's integrate that piece. So we end up with -y cubed over 3 minus y squared over 2 plus 2y from -2 to 1. Let's plug in our 1. So 1 cubed is 1, so I'd end up with -1/3. 1 squared is 1, so I get -1/2. And 2 times 1 is 2. I'm going to subtract, and I'm going to put a big parentheses. Always a parentheses here. Negative 2 cubed is negative 8, and there's already a negative hanging out, so that's going to go positive. And then it's a minus, and then negative 2 squared is 4 over 2, and then 2 times 2 is 2 times negative 2 would be negative 4. I'm going to distribute in this negative that's here, which means I'm changing all my signs. So that's a minus, this is a plus, this is a plus. And then I'm going to use kind of this little shortcut that I have where I'm going to combine my like terms with my fractions and see sometimes that helps and it works out. So negative 1/3 and negative 8/3 is negative 9/3. Negative 1/2 and positive 4/2 is positive 3/2. 2 and 4 is 6. So it looks like if I have to go all the way, I've got negative 3 plus 3/2 plus 6, which is going to be, if I combine these two together, 3 plus 3/2. And if I make that, it's the 3 into halves, that would be 6/2 plus 3/2, which is going to be 9/2.